Hi everyone, welcome to my YouTube channel Zenith GATE Mechanical. So in the today's session, I will discuss the question which was asked in the GATE 2025 engineering science paper from the solid mechanics.
Shows a rod PQ which is hinged at this point, rotating counterclockwise. Counterclockwise means anti-clockwise direction with a uniform angular velocity, okay, 15 radian per second. That means this angular velocity is given as 15 radian per second. Okay, this rod PQ is basically rotating with certain angular velocity, which is nothing but 15 radian per second. A block R, this is the block R, which is translating along a slot cut out in the rod PQ. At the instant shown, the distance PR, at the distance PR is 0.5 meter. Okay. And theta is equal to 60 degree. Theta is equal to 60 degree. The relative velocity of R with respect to rod PQ is 5 meter per second. That means the velocity of R with respect to PQ is given as 5 meter per second. That means this block is sliding over this slot with a velocity of 5 meter per second. Okay. And the relative acceleration of R with respect to PQ is 0. So the acceleration of R with respect to PQ is 0 at this particular instant. Now, which one of the following is correct magnitude of absolute acceleration of block R? Okay, so you have to calculate the absolute acceleration of block R. So how you will calculate? First of all, you will see what are the different types of acceleration which is acting on this particular block. Okay, so let me first draw the free body diagram. So this is basically one link, and this is the joint P. This is basically a rod PQ over which a block which is sliding. So I'm just representing with one point. This is the block R. Okay, if it is sliding, that means there will be some linear velocity along this particular link. So whenever the case, if any particular object is sliding over the link and the link is also rotating, in that particular case, one acceleration will act on that body, which is called as a Coriolis acceleration. Coriolis acceleration. The Coriolis acceleration is nothing but it's 2 times of its angular velocity of link into the linear velocity of this particular block. Block is moving with velocity v in this direction, and the link is rotating with an angular velocity omega in this direction. So the Coriolis acceleration will act. If this link is not rotating angular velocity, that means omega is 0. So Coriolis acceleration value will be 0. But in this case, the link is rotating and the block is sliding in the outward direction. Okay, so this is the Coriolis acceleration. One more acceleration will act, which is nothing but the radial acceleration, which is omega square into r. Okay, omega square into r, which is towards this point P. Now the next thing is, you know that the magnitude of Coriolis acceleration is 2 into omega into v. But how you will identify the direction of this Coriolis acceleration? What you will do, just take the velocity vector and rotate 90 degree in the direction of angular velocity. Okay, so if you rotate this in the direction of omega at an angle of 90 degree, so this is basically the acceleration of Coriolis acceleration of this particular block. Okay, so two accelerations are acting. Coriolis acceleration you can easily calculate. Omega value is given. Is the omega value is given? Yes, omega value is 15, and the velocity which is given as, the velocity is nothing but, what is the velocity? Velocity is nothing but 5 meter per second. So this is 5 meter per second. This is nothing but 150 meter per second square. Okay, this is one acceleration. Now the second acceleration is the radial acceleration. We can say that omega square into r, omega is 15 square. And what is the radius? The radius of this point, that means the distance of this point to P, which is already given, PR is equal to 0.5. So this value is nothing but 0.5, 0.5. Let me check. The value is 0.5. Yes, 0.5 So this is 225 into 0.5. So the radial acceleration value you can easily calculate. So the total acceleration and the net acceleration is nothing but, can I write 150 square, that means Coriolis acceleration is square, plus radial acceleration is square, 225 into 0.5 square. Why I have taken this square plus this square? Because both are at 90 degree. Both are at 90 degree means the square of this and the square of this one. Okay, so once you will solve, the net acceleration value you will get is 187.5 meter per second square. Okay, so what is the correct answer? So the correct answer for this question is option A, which is 187.5. So choice A is the correct answer. Choice A is the correct answer.
Closed thin cylindrical tank with the mean diameter 300 mm and the thickness is given as 2 mm is subjected to a uniform internal gas pressure. The allowable shear stress on the curve wall of tank is 70 megapascal. Based on the Tresca theory or Tresca criteria, which one of the following option for maximum safe value of P is correct? Okay, that means based on the Tresca theory, you have to calculate what is the maximum value of the pressure which will be the safe in this particular condition. Okay, so you know that in case of thin cylindrical tank, there will be the two different type of stresses. One is called as a longitudinal stress, which is PD by 4T, and there is a hoop stress, which is nothing but PD by 2T. Okay, so this hoop stress is also known as a major principal stress, and this is the minor principal stress. Okay, maximum value of shear stress is the larger of sigma 1 minus sigma 2 by 2, sigma 1 by 2, and sigma 2 by 2. So you have to identify which one will be the maximum value. So the maximum value of shear stress larger of sigma 1 minus sigma 2 means this is, let us suppose, PD by 2T minus PD by 4T divided by 2. Sigma 1 by 2 means PD by 4T and sigma 2 by 2 is PD by 80. PD by 80. PD by 80. So from this particular value, you will get PD by 80 only. This is also PD by 80. So which one will be the maximum? PD by 40 only. So you will equate this with the allowable stress. So PD by 40 is the maximum value, and the allowable stress value, which is given as 70 megapascal. 70 megapascal. Okay. So you just equate with 70 megapascal, then you will get the pressure. So the pressure is equal to 70 into 4 into thickness. What is the thickness? 2 divided by what is the mean diameter, which is 300 mm. Okay, once you will solve, then you will get the pressure value approximately 1.87 megapascal. That means the option D is the correct answer for this question. Okay.